Welcome to Researchers and Authors. My name is Marwa Matez Ismail Al Nusour University College, Iraq, Baghdad. The paper name is Parasitic Slotted Patch Antenna for Dual Band Operation over S-band. The abstract is the microstrip patch antenna is widely used in antenna design and for various purposes due to its features. However, it suffers from two significant drawbacks. Number one, the lack of gain, and number two, the narrow bandwidth. This paper presents a low-profile antenna with a simple design and low cost, making it very suitable for array applications. An improvement in gain and bandwidth has been achieved. The antenna is designed using a substrate with a relative permittivity of 4.08, thickness of 1.5 mm, and a coaxial fitting technique. Simulations are performed using the CST design tool. Parasitic patch antenna with a slotted technique was used to achieve dual band operation with consistent gain and linear polarization over the operational bands. The antenna configuration of two patches with the cross-slotting along with the second patch. This structure achieves reflection coefficient S11 less than 22 dB, dual bandwidth with gain equal to 5.7 dB and 4.06 dB over the operating bands. The parameters of the antenna design. Parameters: sample, proposed antenna. Patch width 41 mm, patch length 30 mm, dialectric constant 4.08, substrate height 1.5 mm, substrate length 80 mm, substrate width 80 mm, feed position 5 negative 30, slot width 3 mm, slot length 25 mm, the gap between the substrates is equal to 1 mm. The main design elements is the driving element, the parasitic element, the slotted patch fitting technique. The driving element is the essential element connected directly to the feed. The antenna dimensions are calculated to depend on the design equations and adjusted in CST software to give the best performance in terms of gain and impedance bandwidth. Parasitic element. It is a radiating element that is introduced to excite multiple resonances. In our design, it has the same dimension as the driving patch and is placed slightly higher than the main patch. By means of the coupling between the driving patch and the parasitic element, the bandwidth can be increased greatly. Furthermore, multiple resonances can be achieved using the slotting patch technique. In our design, across rectangular slots are inserted into the parasitic element to achieve a dual band operation with consistent gain over the operational bands. Slotted patch. For achieving multiple resonances with a good gain, rectangular cross slits are added to the parasitic element. Dual band operation with impedance bandwidth S11 less than 23 and S11 less than 25 dB, along with gain equal to 5.7 and 4.06 are achieved over the operational bands. And the last one is the feeding technique. As we know, the antenna input impedance must match the source impedance of 50 ohm for all radio frequency and microwave sources. The antenna acts as an impedance converter between the free space impedance and the 50 ohm source impedance. So, a feeding technology that achieves an internal resistance equal to 50 ohm is considered and applied. This is the coaxial feed. The coaxial feed is a constant feed technology that delivers energy to the patch through a direct path. Coaxial feed is a non-planar feed technique where a coaxial cable is used to feed the radiator. The outer conductor of the cable is grounded and the inner conductor of the cable penetrates the insulating substrate, making metallic contact with the patch, as shown here. One of the advantages of the coaxial feeding technology is the possibility of placing the coaxial probe at any point inside the patch to fully match with the input impedance. So, by controlling the feeding position, we have a great match that will be very good for the antenna design. Moreover, the ground plane isolates this prior radiation, which makes the performance better. The feeding location is indicated by X and Y coordinates, and as given in this table, it is just 5, -30. This is the feeding position. It has a very important role in the impedance matching. So we can have match by just controlling this feed position. Now this is the antenna design. This is the final antenna design. This is the parasitic radiator, and this is the rectangular cross slots. This is the substrate, and here you will find the results. This result is before adding the parasitic element. As you can see, there is only one band, and this band is, and the S11 is less than 40. And after we added the parasitic element, as you can see, we achieved a dual band operation, and the S11 and the impedance bandwidth is increased. The S11, as you can see, is less than -20 and less than -25. This is the S11 results. Here we can find the radiation pattern for the two bands. This is the band, the first band, this is the radiation pattern equal to 5.7 dB, and this is for the second band, the radiation is equal to 4.06. This is the gain, and it's almost consistent. So this is the proposed design. This objective is to make multiple resonances with good gain and good impedance matching. The conclusion: with the development of communication system and the need to expand the frequency range and antenna efficiency to an acceptable level from this urgent need, and to keep up with the rapid change of communication system, various techniques have been employed to increase the antenna's efficiency, gain, and bandwidth. In this paper, a parasitic slotted patch with a loaded patch antenna was designed to enhance the bandwidth and gain of the microstrip patch antenna. At first, the feeding technique that gives the best results in terms of gain and S11 was selected. The location of the feed point is very important, and their coordinates has a significant influence on the result. And the point 5, -30, was chosen to give it the highest S11 and gain. After tuning the parameters and select the best value for the design, a parasitic antenna was added with the exact coordinate of the original antenna. Crossed rectangular slots were added to the parasitic floated antenna to increase the operating bands and gain. The slotted technique significantly increased the bandwidth to dual bands with impedance bandwidth less than -23 and -25. Gain equal to 5.7 and 4.06 over the operational bands. The proposed design can operate over dual band with good gain. It has a low profile with a simple design and low weight, making it suitable for array application. Thank you so much for your listening.